Welcome to The Explainer. So, today we're tackling a cosmic mystery that honestly sounds like it should be impossible. We all learn that the universe is expanding, right? Everything's flying away from everything else. So, how is it that we are on a direct collision course with our biggest galactic neighbor? Let's get into it. This quote is such a perfect way to picture what's happening. Think about it. The universe is this huge ocean, and every little cluster of galaxies is like a ship. On our ship, there's a party going on. We're all close enough to bump into each other. But all the other ships, they're just sailing away from us, getting further and further out. It really captures this weird duality of a universe that's both pulling together and flying apart at the exact same time. Okay, so to really understand this mystery, we need to meet the main characters in this whole cosmic drama, the galaxies themselves. And believe it or not, their shapes and sizes give us some pretty big clues. First up, you've got your spiral galaxies, just like our home, the Milky Way. They're these beautiful, giant, rotating pinwheels of stars and gas, just absolutely bustling with activity. Then you have the ellipticals. Now these guys are different. They're these massive, blob-like collections of older stars. And here's the first real hint. They're often the result of other galaxies crashing into each other. And finally, you get the irregulars. Their chaotic shapes are a total giveaway that they've been yanked around and twisted by the gravity of their neighbors. This is proof that galaxies don't just exist in a vacuum, they interact. And that brings us right back to the central puzzle. Look, ever since Edwin Hubble, we've known for a fact that the universe is getting bigger. The actual fabric of space-time is stretching, and it's carrying all the distant galaxies away from us. So how in the world can anything be moving towards us? Okay, so here it is, laid out plain and simple. Fact 1, the universe is expanding, and distant galaxies are speeding away. Fact 2, our next-door neighbor, the Andromeda Galaxy, is hurtling straight for us at over 100 kilometers a second. A collision is basically guaranteed. How can both of these things be true? Well, to figure this out, we have to zoom out, way out. The first big clue isn't inside any one galaxy, but in how all of them are arranged across the universe. And it turns out, it is not random at all. What scientists found is this incredible structure they call the cosmic web. Just picture these unimaginably long filaments of light stretching across the universe, with galaxies strung along them like beads on a string. And wherever those filaments cross, you get these super dense, massive clusters of galaxies. This shows us, right away, that some powerful force is pulling matter together, fighting back against that cosmic expansion. So the cosmic web tells us something is holding everything together. Our next clue comes from scientists looking really closely at individual galaxies and finding something that seemed to break the known laws of physics. Back in the 70s, the amazing astronomer Vera Rubin was studying how spiral galaxies spin. Now, she expected the stars on the outer edges to be moving way slower than the ones in the middle. Just like the outer planets in our solar system move slower than Mercury. But that's not what she saw. The outer stars were moving just as fast. The only way that's possible is if there's some huge, invisible halo of mass surrounding the entire galaxy, holding it all together. And this chart really just blows my mind. It puts that discovery into perspective. Everything we can see, every star, every planet, you, me, all of it, is in that tiny little slice of normal matter. Less than 5% of everything. The rest of the entire universe is made of two things we can't see or touch. So the first of those invisible things is dark matter. This is that unseen mass that Vera Rubin's work pointed to. It's completely invisible, but it has a ton of gravity, and it acts like this cosmic glue, forming the scaffolding for the cosmic web and holding galaxies together, keeping them from just flying apart. All right, so dark matter is the glue holding things together locally. But that still leaves the other half of the problem. What's the force that's pushing everything apart on the grand scale? Well, that would be the single most mysterious thing in all of science, dark energy. It's almost like anti-gravity. It's a repulsive force that seems to be part of space itself. And in the vast empty voids between galaxy clusters, there's so much of it that its push overwhelms everything else, forcing the universe to expand faster and faster. So here's the answer. It's a cosmic tug-of-war. On local scales, like on our ship, the gravity from all the dark matter is super strong, and it easily overpowers the push of dark energy. It's pulling our whole local group of galaxies, including Andromeda, into a big gravitational huddle. But on cosmic scales, in the enormous emptiness between the ships, dark energy wins.
There's just more space for it to act on, so it pushes all the clusters apart. Simply put, gravity wins locally, and dark energy wins globally.
But solving one mystery just opens up another, even bigger one. To really understand these strange dark forces, scientists are now building the most detailed map of the universe anyone has ever even dreamed of. This incredible project is called DESI, the Dark Energy Spectroscopic Instrument. Get this, it uses 5,000 tiny robotic eyes that reposition themselves every 20 minutes to look at a new patch of sky. It's mapping millions of galaxies to create this giant 3D map of cosmic history. And the goal is to see how dark energy has behaved over time. The very first results are already hinting that dark energy might not be constant, which, if it's true, could change everything we think we know about the fate of our universe. And that leaves us with this number, 95%. After all this incredible science, all these discoveries, that's how much of our own universe is still a complete and utter mystery to us. This invisible world of dark matter and dark energy that we're only just now beginning to understand. So it all leads to this final thrilling thought. This whole cosmic tug-of-war is just one piece of a much, much bigger puzzle. As we start to map out this invisible universe, what other incredible secrets are we going to find? It just reminds you that the more we learn, the more we realize the real adventure is just getting started.